All right, everyone get ready because we are diving into Meta's latest paper, Meta Audiobox Aesthetics, Unified Automatic Quality Assessment for Speech, Music, and Sound. You know, keeping up with all this new audio AI research can feel like drinking from a fire hose, right?
It really can be a lot.
So in this deep dive, we're going to break it all down.
Absolutely. We'll sift through all those technical details, pull out the key insights that you actually need to know.
We'll explore how this new model from Meta, this Audiobox Aesthetics, how it could totally change the game, how we think about evaluating audio quality. I mean, think about all those applications.
Definitely.
From data filtering and pseudo-labeling all the way to evaluating those incredibly complex generative models that are coming out now.
Yeah.
This is going to be huge. So for the first minute, let's give everyone a quick summary of the key points of the paper.
Sounds good.
All right, so Meta has come up with this new model. They're calling it Audiobox Aesthetics, and it can automatically assess the aesthetic quality of any audio you throw at it. Speech, music, sound effects, the whole shebang.
It's impressive.
Now, here's the really cool part. It's not just giving you a single, ambiguous quality score.
Right.
They actually developed a new annotation guideline that uses 4 axes to evaluate the audio.
Yeah.
So those are production quality, production complexity, content enjoyment, and content usefulness.
That's right. And they trained this Audiobox Aesthetics model on a massive data set.
Over 97,000 audio samples.
Huge. It covers all sorts of audio types: speech, music, sound effects.
Which means it's pretty robust, right?
Yeah, and in objective evaluations, it actually outperforms the existing models that are out there.
Which is really impressive.
Yeah.
And then they didn't stop there.
Yeah.
They went on to explore how Audiobox Aesthetics could be used in downstream tasks like text-to-speech, and the results are super promising.
They are. It actually seems like it could enhance the quality of generated audio.
Pretty cool stuff.
Wow.
Okay, now let's unpack all that.
That's good.
Let's start with the problem that Meta is trying to solve here. Traditionally evaluating audio quality, especially when it comes to those aesthetic aspects, it relies heavily on, human listeners.
It does.
And that can lead to inconsistencies.
Yeah, and it's expensive.
Super expensive.
Yeah.
And it's really slow.
Yeah, it's not really scalable.
Not scalable at all, especially with the rise of these complex generative audio models that we're seeing now.
Exactly.
Like, we need automated systems that can keep up.
We do.
And that's exactly where Audiobox Aesthetics comes in.
It does. So, as we mentioned, this Audiobox Aesthetics model, it's really unique.
It is.
Because it goes beyond those single ambiguous quality scores that we've been using.
Right. It's much more nuanced.
Much more nuanced, exactly.
Let's dive into those 4 axes of aesthetic evaluation that they came up with.
Okay.
You want to start with production quality?
Sure. So production quality, it really focuses on the technical aspects of the audio.
Okay.
Things like clarity.
So how clear is the audio?
Exactly. Dynamics, so the range between the loudest and softest parts.
Right.
Spatialization, how well does it utilize the stereo field?
Okay.
So basically how well produces the audio, regardless of what it actually is, what the content is, or anyone's personal preferences.
Got it. So that's like the objective measure.
In a way, yeah.
Now, production complexity. This one's really interesting to me.
Yeah, this one's super cool. They're actually trying to measure the number of audio components in the sound.
Okay.
So think about it like a symphony orchestra. That would probably score higher on production complexity.
Then, say, a solo flute.
Exactly.
Interesting. I like that.
It adds this whole other layer to how we analyze audio, don't you think?
I do. Okay, so we've got the technical side, and then we bring in the human element with content enjoyment.
Right.
Which acknowledges that, hey, audio quality isn't just about perfection.
Yeah.
It's also about how it makes you feel.
Exactly. How much someone enjoys listening to it, the emotional impact, personal preferences, all that comes into play here.
And then we've got content usefulness. So how likely is someone to actually use this audio for, creating something?
Right.
Whether it's a podcast, a film, a video game, whatever.
Yeah, so it's a very practical axis. It's really intriguing, I think, especially for this audience.
I think so too.
Yeah.
Especially for people working with generative models or curating these huge data sets.
Absolutely.
All right, so they've got these 4 axes.
Yeah.
Now let's talk about how they actually built this model.
Okay, so they started with a massive data set, as we mentioned.
97,000 audio samples.
Right, covering speech, music, sound effects, pretty much everything.
But I think what's even more important is how they annotated that data.
Yeah, their process was super rigorous. They wanted to make sure they were getting really high quality annotations.
So walk us through that.
Okay, so first they sampled audio from a ton of different sources.
Yep.
So they had a lot of variety.
Right.
And then they normalized the loudness of all those samples.
Makes sense.
So that loudness wasn't a factor in the ratings. And then, and this is really interesting, they actually implemented a rater qualification program.
Oh, what? Hold on. A rater qualification program.
Yeah, so basically...
That sounds intense.
It was. To make sure all the raters were, on the same page, they had to evaluate what they called a golden set of audio samples.
Okay.
And these samples, they already had expert annotated scores.
So they were like the gold standard.
Yeah, exactly. And only the potential raters whose ratings were really close to the expert scores, only those people actually made it into the program.
Wow. Okay. So they really went all out to make sure the data was top notch.
They did. It really emphasizes how important that rigorous methodology is.
It does. It makes sense, though. If you're going to build a robust and reliable model, you need that solid foundation.
You really do.
Okay, so they've got the data.
Yeah.
What about the model itself?
Okay, so for the model architecture, they decided to go with a transformer-based architecture, which, as you probably know, transformers are really good at handling sequential data, like audio waveforms.
Right.
And they used a WaveLM-based encoder.
WaveLM, okay, yeah.
Which you might remember from its, amazing performance in speech recognition tasks and sound classification.
Oh, yeah.
So it's got a pretty good track record.
Yeah, it does. So they're building on some pretty serious technology here.
They are.
But how does it actually work? I mean, you give it an audio file, and it spits out these 4 aesthetic scores. What's happening under the hood?
Okay, so the paper actually goes into a lot of detail about the embedding process.
Okay.
Specifically, you can check out equations 1 to 3 in the paper if you want to get really into the weeds. But essentially, they're extracting a single embedding vector from multiple layers and time steps of the transformer model.
So it's like condensing all the important information about the audio into one code.
Exactly. It's like a fingerprint for the audio.
And then the model uses that fingerprint to predict those 4 aesthetic scores.
That's exactly it.
Okay, that makes sense. Now let's get to the really exciting part. The objective evaluation.
All right, let's see how it actually performs.
So they tested this model on public data sets, right?
Yeah.
Like VMC22, which has a bunch of speech samples.
It does, in both English and Chinese, which I think is a good way to test.
How robust the model is.
Exactly. Can it generalize beyond just a specific language?
And can it handle, out-of-domain scenarios?
Right.
Because the Chinese samples, they weren't part of its training data.
Yeah, they weren't. And it did great.
Really?
Yeah, even on those Chinese samples, the model had really good performance. It was comparable to or even better than the other models that are out there.
That's really impressive.
It is. It suggests that the model is actually picking up on some of those fundamental aspects of audio quality that go beyond just the language.
Okay, so it can handle speech. What about other types of audio, like music and sound effects?
Yeah, they tested it on those as well.
They did?
Yeah, they used the PAM sound and music datasets, which contains both natural and synthetic audio.
Interesting. And what do they find?
Well, for music, the model was really good at predicting overall quality, but it had a bit more trouble with sound effects, which, it makes sense when you think about it.
Yeah.
Sound effects are just so diverse and less structured than something like music.
Yeah, sound effects can be anything.
Exactly. From a simple clap to, a bustling city street.
Yeah, so that must be pretty hard for the model to find those consistent patterns.
Right. There's just so much variability. But here's something interesting. They found that content enjoyment played a much bigger role in overall quality judgments for music than for sound effects.
So you're saying that people are more likely to rate a piece of music as high quality if they actually enjoy listening to it?
Exactly.
Even if it's not technically perfect?
Even if it's not perfect, yeah.
That's fascinating.
It is. It really highlights the importance of that subjective emotional response when it comes to music.
It does. I wonder if we could use this to predict which songs will become hits.
Maybe. It definitely opens up some really interesting possibilities for the music industry.
Yeah, it does. Okay, so they tested it on those public data sets?
Yeah.
Did they test it on anything else?
They did. They actually created their own data set.
Oh, really?
Yeah, they called it AES Natural.
AES Natural, okay.
And it's a really valuable resource for the research community. It's got over 2,950 audio samples.
Wow.
Yeah, and it's got speech, music, sound effects, all annotated, meticulously annotated for all 4 of those aesthetic axes.
Really?
Yeah. And guess what? Audiobox Aesthetics, it totally outperformed all the other baseline models on this data set as well.
No way. So they've got a powerful model.
They do.
Massive data set.
Uh-huh.
And rock solid results.
Yeah, they've caught it all.
But now let's talk about the practical applications. I mean, how can we actually use this technology?
Right, that's the important question.
Because that's what our listeners really care about.
Absolutely. So Meta, they actually explored how Audiobox Aesthetics could be used to improve those downstream tasks.
Like text-to-speech, text-to-music, text-to-audio generation, things like that.
Okay.
They focused on 2 main strategies, filtering and prompting.
Filtering and prompting. Okay, break those down for me. What do they mean by filtering?
So with filtering, you're essentially using Audiobox Aesthetics to handpick the best audio samples to use for training your models.
Okay, so you're kind of curating the super refined data set.
Exactly.
So you're making sure that the model's learning from the best of the best.
That's the idea. You're giving it a gourmet meal instead of fast food.
I love that analogy. Okay, what about prompting?
So with prompting, you get a little more strategic. You're actually incorporating those aesthetic scores directly into the input prompts that you give your model.
So you're not just feeding it text, you're also giving it guidance on what kind of aesthetic qualities you want in the output.
Exactly. So instead of just saying, here's some text, make me some audio, you're saying, here's some text, make me some audio that scores high on production quality and content enjoyment. Okay, that's really cool. So you're kind of like whispering in the model's ear.
You are.
All right, and they found that prompting was actually more effective than filtering.
That's what they found, which is really fascinating, I think.
It is. Why do you think that is?
Well, it seems like prompting strikes this really nice balance between control and creativity.
Okay.
So you're guiding the model, but you're not limiting its potential.
So it still has some room to breathe.
Exactly. And what's really exciting about all of this is that Meta, they actually open sourced their model.
They did.
And the data sets.
That's huge.
Yeah, it is. So now anyone can play around with this technology, try it out for themselves.
So all you AI audio wizards out there listening, go download the model.
Yeah.
Play around with it.
See what you can do.
Push the boundaries. See what you can create.
Exactly. This research has opened up a whole world of possibilities for audio AI, and we're really just scratching the surface here.
I know, right? There's so much more to unpack. Stay tuned, everyone.
Yeah, we'll be right back.
We'll delve even deeper into the implications of this groundbreaking research after a quick break. Okay, so we're back, and we're going to continue talking about Meta's Audiobox Aesthetics. You know, before the break, we were talking about how well this model performed on all those different data sets they tested it on, even on those Chinese speech samples, which were totally outside of what it was trained on.
Right. It really shows how good the model is at adapting, like picking up on those universal qualities that just make audio sound good, no matter what the language is or what the content is.
And I think that's super relevant for what we do, you know, with AI audio.
Totally.
Always trying to push things further with speech synthesis, music generation, all of that. A tool like this, it could totally change the game for how we evaluate and improve these models.
Absolutely. Imagine being able to just analyze any audio you generate, just automatically get feedback across all 4 of those axes: production quality, production complexity, content enjoyment, content usefulness.
It would be amazing.
It would give you so much insight into where your model might be lacking or where it's really strong, like what's working, what's not.
It'd be like having an audio critic on call, 24/7, just giving you super specific feedback to help you make your models better.
Exactly.
And, you know, you were talking about how Meta explored using this for downstream tasks.
Yeah.
Like text-to-speech.
Right.
And they found that just by filtering the training data, picking out only the best samples, the highest quality ones, based on the model's scores, they could make the synthesized speech sound much more natural, just overall better.
Better.
Which makes perfect sense.
It totally does. You know, it's like you were saying, you're giving your model this amazing, healthy diet, only the good stuff, none of the junk, garbage in, garbage out. Right.
Exactly. But we were talking about that other strategy, too, before the break.
Right. Prompting.
Which is even cooler, in my opinion.
Yeah, prompting's super interesting. Instead of just throwing out the bad examples, you're actually taking those scores, those aesthetic scores, and you're putting them right into the inputs that you feed the model.
So you're basically giving it directions on how to create audio that hits those specific quality levels.
Exactly. You're saying, hey, model, I want you to make this, but make sure it's got high content enjoyment, keep the production complexity at a moderate level. Things like that.
So it's more than just filtering, it's giving it instructions.
It is. And what's crazy is they found that prompting could actually be even more effective than filtering for boosting the overall quality.
Really?
Yeah.
That's wild.
It is, and it kind of makes sense when you think about it. It seems to give the model that perfect mix of control and that freedom to be creative.
So you're guiding it, but
Yeah.
you're not putting it in a box.
Exactly.
That's a powerful finding. It seems like we could be doing so much more to get even better quality out of these models,
We can.
just by working on those prompts, making them more specific, more nuanced.
Absolutely.
And the coolest part is that Meta, they didn't just keep this to themselves.
It didn't, thankfully.
They open sourced the model and all the data sets, which means anyone can get their hands on this.
Anyone can.
So to all the AI audio people listening, you can download this right now.
Go for it.
Play around with it, try it out on your own projects. I'm excited to see what people come up with.
Me too. This whole research project, it's just opened up so many doors for audio AI. We're just starting to explore all the possibilities here. It feels like a whole new era for audio creation and evaluation. It's pretty exciting stuff.
It really is. But we should also be realistic here.
Definitely.
You know, with great power comes great responsibility.
It's true. We can't just blindly accept all this amazing technology without thinking about the potential downsides.
Absolutely.
Yeah.
As we keep diving deeper into these AI-driven ways of looking at aesthetics, we've got to be careful.
We do. We have to be mindful of those pitfalls, those biases that could creep in. Like, imagine a text-to-speech system, right? And it's always generating voices that sound more authoritative or trustworthy, but only for certain types of people.
Right.
That could have some real-world consequences.
It could.
We have to be very careful and make sure these systems are being used ethically. You know, they need to be fair, they need to be inclusive.
They do. It's a balance, for sure. We need to be having these conversations as a community. We can't just get swept up in all the cool tech stuff without thinking about the bigger picture, the ethical implications.
Yeah, it's a conversation we need to keep having.
Absolutely. So, yeah, we need to approach this new era of audio AI with a good balance of excitement and caution. Make sure these tools are being used to create something positive, something that benefits everyone.
Well said. That's a perfect way to transition to the final part of our deep dive. When we get back, we're going to take a look at some of the broader implications of this research.
What could this mean for the future of audio AI? What could it mean for the future of, content creation in general? We're going to tackle all of that when we come back. Stay tuned. And we're back for the final part of our deep dive into Meta's Audiobox aesthetics.
It's been a really interesting conversation so far.
It has. We've covered a lot of ground. Those 4 innovative axes of evaluation: production quality, production complexity, content enjoyment, and content usefulness. And we talked about how this model is already making waves in downstream tasks like text-to-speech.
Yeah, it's pretty impressive.
But before we wrap up, I want to go back to one of the most surprising things we learned. The idea that prompting might actually be a better way to improve audio quality than filtering.
Right. That was definitely a head scratcher for me at first.
I mean, filtering seems so logical on the surface. You're training your model only on the best of the best, those top-tier audio samples.
Yeah, you'd think that would be the key, right? But it seems like by being so picky, we might be holding the model back.
Like we're putting blinders on it, only letting it see this tiny part of the audio world.
Exactly. But with prompting, we're giving it more freedom to explore while still kind of nudging it towards the qualities we want.
It's like instead of saying you can only learn from these examples, we're saying, hey, here are some things I like, but feel free to experiment and see what you come up with.
I like that. It's a much more collaborative approach to training these models.
And it seems to be working. They're getting some really impressive results with prompting.
They are. And I think it says something about how we're starting to think about AI and creativity. We're not just programming machines anymore. We're finding ways to actually partner with them to unlock new levels of artistic expression.
That's a really interesting way to put it. It's like this delicate dance between giving the AI guidance and letting it have some autonomy.
Definitely. We need to give it the right tools and direction, but we also have to give it space to surprise us.
And I think that's what makes this research so exciting. It's not just about building better models. It's about completely rethinking the creative process itself. How humans and AI can work together to make amazing things.
I agree. I think we're just scratching the surface here. We're only beginning to understand what AI can do for us, creatively speaking.
It makes you wonder what the future holds. Imagine being able to just create music that perfectly captures a certain emotion. or design soundscapes that can transport you to another world.
I know, the possibilities are really endless. And now, with tools like Audiobox Aesthetics, we can actually start to measure and understand these creative outputs in a much deeper way.
This research has given us a whole new perspective on audio,
Yeah.
and I think it's going to inspire a ton of innovation in the years to come.
I think so too. It's a really exciting time to be working in this field.
It is. Well, thanks for joining us on this deep dive into Meta's Audiobox Aesthetics. Hopefully you found this as fascinating as we did. Until next time, keep exploring, keep creating, and keep pushing those boundaries of what's possible with audio AI.